Seismographs are what scientists use to measure earthquakes. What they are is just a beam attached to the ground with a weight that can swing freely attached. As the earth shakes, the weight stays in place and draws a line on the piece of paper below. So the less the ground moves, the more straight the line will be on the piece of paper, and the more the ground moves, the more movement the line will have on the piece of paper.
Tomorrow we'll be modeling how a seismograph works.
So in your bin, you have plate A, plate B, and the string plate. A and plate B should be set up looking like this, so that this little ridge is connected. The plate with the string is going to attach to plate B over this metal bar, like so. To fold the blank piece of paper the long way in half, like so, and place it underneath the swinging bar on the string plate. Place one of your toothpicks in the ridge between plate A and plate B. Take the cap off your dry erase marker and put it on the back of the marker so that you don't lose it. Then you can put the dry erase marker into the hole on this swinging bar. Make sure it's nice and centered. Once you have your seismograph set up like this, then you can get people into their roles. So there'll be a person who's in charge of plate A, holding it down firmly against the table and making sure that the side of their hand is keeping the toothpick in place. The plate B person is going to firmly grasp plate B, and when the time comes, they're going to push plate B forward. Then there's going to be another person who's in charge of the string, and what they're going to do is they're going to gently pull the string consistently towards themselves throughout the earthquake. So we've removed the toothpick and the marker so that we don't spoil the surprise, but it is important. It's useful to keep a small gap between plate A and plate B, just so it's a little bit easier for the plate B person to break the toothpick. But we're going to demonstrate for you how this works. So again, the plate A person is going to firmly hold plate A against the table. Plate B person is going to push plate B forward till the toothpick breaks, and the string person is going to be pulling the string while that happens. Now the person who's not operating the seismograph is going to be counting down from 3 to 0. At 1 is when the string person is going to start pulling the string, and at 0 is when plate B person is going to move plate B to try to break the toothpick, like this. 3, 2, 1, 0. It's important for the string person to keep on pulling the string even after the toothpick breaks, but make sure to stop before the end of the paper, because otherwise you'll be spending lunch with me cleaning my tables, and you don't want to do that. Let's hear those instructions one more time. Now the person who's not operating the seismograph is going to be counting down from 3 to 0. At 1 is when the string person is going to start pulling the string, and at 0 is when plate B person is going to move plate B to try to break the toothpick, like this. 3, 2, 1, 0. It's important for the string person to keep on pulling the string even after the toothpick breaks, but make sure to stop before the end of the paper, because otherwise you'll be spending lunch with me cleaning my tables, and you don't want to do that. Once you've produced your first seismogram, you can keep on rotating through the different rolls until you've produced 8 seismograms. You should be able to get 2 seismograms per piece of white paper just by flipping the folded piece of paper over. All right, that's it. Remember, as always, you can rewind or rewatch any part of this video if you didn't get all the answers to the flipped class sheet. I hope you enjoy the lab tomorrow. I'll see you next time.
Mr. Wong's Lab Class.